Hello friends, this is going to be the second video on transformation of two-dimensional random variables. There are going to be basically four different types of transformation: u equal to xy, u equal to x by y, u equal to x plus y, and u equal to x minus y. We have seen about the transformation u equal to xy in the first video. We will see what happens in our second video. The problem is like if x and y are going to be independent random variables with f of x is e power minus x into u of x, and y has been given as 3 e power minus 3y into u of y, where u is going to be the step function, unit step function. Find the PDF of z is equal to xy. Now, a little twist over here. The thing is that the random variables x and y are not transformed to u and v, but since the unit step function u appears over here in the function f of x, they have given us another more variable called as z. So we are going to transform it to the variable z, and let us fix one more variable for v rather than the keeping the same variable. So let me take it as w. So my transformation is going to be from the variables x comma y to the variables z comma w. This is how we are going to define the transformation for this problem. And the type of transformation is going to be z is equal to x by y for this case. So we have a totally 6-step method which can easily help us solve this problem on two-dimensional transformation. So we will see what are going to be there. Then we'll have to have a old function called as x comma y. We convert it into the new joint PDF called as z comma w, and this is going to be aided by the Jacobi of transformation. So we will be fixing the required quantities, and we will be trying the new joint PDF of z and w, and then making use of it we will be able to estimate the PDF of z. Now coming to step 1, we have been defined what is our z. Our z has been defined as x divided by y, but we don't know what is going to be the relationship of the second variable w. So what we do is we fix the auxiliary random variable y to be equal to w. So what we do over here is we fix the random variable y as w. That is, the second random variable over here is now assigned to w. Let us fix the joint PDF f of x comma y. We don't find anything called as f of x comma y appearing over here in this problem. Therefore, we are to find the value of f of x comma y. Now, how to find this f of x comma y? What are the data which has been given to us related to it? We have been said a point over here like x and y are going to be independent random variables. So what do you mean by independent random variables? They can act separately. In which case I know that my f of x comma y can be written as f of x product f of y. So this is going to be the key formula for me to fix my old function f of x comma y. So now f of x has been given to me. So this is going to be my f of x, and I have it to be e power minus x into u of x. What is this u of x? U of x has been stepped as unit step function. What is an unit step function? It is a function that takes the value unity or unit or 1 whenever the value of x is going to be greater than or equal to 0, and it is going to be 0 elsewhere. So now I can fix this f of x as e power minus x times of 1, where my x is going to be greater than or equal to 0. And it is going to be 0 elsewhere means this multiplied with 0, what will happen? This entire function will vanish. Now going on to the second quantity f of y. What do we know about f of y? We have been given that as 3 e power minus 3 times of y into u of y. Again, what is going to be u of y? It is unit step function that takes the value 1 for y greater than or equal to 0, and is going to be 0 elsewhere. So I multiply this u of y as 1 whenever I take the range to be y greater than or equal to 0. So I have my old function f of x comma phi, the joint old PDF of x and y, to be fixed as e power minus x into 3 power 3 e power minus 3y, valid for x greater than 0 and y greater than 0. So the first two steps are over. We move on to the third step. What is the third step? Find the relationship of z and y in terms of z and w. X and y in terms of z and w. X and Y are our old variables, Z and W are our new variables. What is going to be given to us? We have been given as Z is equal to X divided by Y. And what did we do in our step 2? Step 1, we fixed our Y as W. So we fixed our Y to be equal to W. So my one set of rule has been got. The next thing is fixing my X in terms of the other variables. From over here, what can I say about my X? My X is going to be equal to Z times of Y. And what I know about Y can be fixed as W. So X now gets fixed as Z times of W. So X will be Z times of W. Now the next step is Jacobian of transformation. What is going to be the Jacobian of transformation? My Jacobian is nothing but determinant of X with respect to Z, X with respect to W, Y with respect to Z, and Y with respect to W. So if I am able to find the 2 cross 2 determinant of this, then that is going to be my value of Jacobi. Now let me differentiate my X partially with respect to Z. With respect to Z, W is a constant, Z on differentiation gives you 1. Now moving on to the next quantity, X with respect to W. With respect to W, Z is a constant, W on differentiation with respect to W gives you 1. Next, moving on to Y with respect to Z. I don't have a Z present in the picture, so the value is going to be 0. Now, Y with respect to W, the W with respect to W gives the value as 1. So, go put your inputs over here in the Jacobian value. So, the value of the Jacobian will be equal to, you can just put your inputs over here. So, we have it to be equal to W, Z, 0, 1. Now how to get the value of the 2 cross 2 determinant? Just cross multiply it and subtract it from one another. So it is 1 time of W, which is W, minus 0 times of Z, which is 0. So I get the value of Jacobian to be equal to W. Now my step 2 and step 3 will help me fix the step 4. What is my step 4? The new joint PDF of Z and W. How I am able to find this? Using the formula for transformation, which is given as modulus of the Jacobi value multiplied by the old joint PDF f of x comma y. What did we know about the Jacobi value we just now arrived at? It is going to be W. So fix that W. What we know about f of x comma y? We have found the f of x comma y as e power minus x 3 e power minus 3y. Let me bring this 3 to the front. So I can write it as 3 e power minus x e power minus 3y. So let me go and attach it over here. 3 times e power minus x e power minus 3y. Now this is going to be my function of z and w, but I can see a glitch over here, like I have the old variables x and y which are present. So we will try to convert it entirely at function of z and w. So how will this be replaced as e power minus, what do you know about x? We know that x is equal to z times of w. So go replace it over here, z times of w. And this becomes e power minus 3 times. How to replace this y with? We know that y can be replaced with that of w. So go and replace it. This is becoming 3 times of w. So now I can now simplify this as 3w e power. This can have minus w to be taken as common, leaving you with z plus 3. So this is going to be my new function of transformed quantity z comma w as 3w times e power minus w into z plus 3. Now this function has been defined. To completely define the function, we need the space where my z and w are valid. So my step 5 will aid it. What is the step 5? The range space of z and w. How to estimate it? From the old range space. What is my old range space? That is going to be the space of x and y. What do we know about x and y's space? We know that unit step function is valid for x greater than 0 and y greater than or equal to 0. So I have x greater than or equal to 0 and y greater than or equal to 0 to be my old space. So I have x to be greater than or equal to 0, my y to be greater than or equal to 0. Now let us try plotting these things. So what I have is going to be the quantity. Let me take this as a y-axis and let me take this to be my x-axis. So this is going to be y and this is going to be x. We have x equal to 0. What is going to be x equal to 0? Your y-axis. And what is going to be y equal to 0? Your x-axis. Now let me go for the portion which is going to be x greater than 0. X is the 0. This is going to be my lower portion, x less than 0, and this is going to be my x greater than 0. So what I want is only x greater than 0. So what I do is entirely go in this direction, covering the entire range from 0 to infinity. So this is going to be my space called as x greater than 0. So this is my x greater than 0. Now moving about the second quantity y, what is going to be y? Y is going to be greater than 0. Where is y equal to 0? This is my y equal to 0. This is going to be the negative parts of y, leaving y as minus 1, minus 2, minus 3 and so on. This is my positive part of y going as y equal to 1, 2, 3 and so on. So when I want y to be greater than 0, I will be moving along this direction, filling my quantities from, rather than this way, I can draw in this way, moving from y equal to 0 to y equal to infinity, y equal to 0 to y equal to infinity. So this is going to be my stretch where my y is going to be greater than or equal to 0. So I see that the range space of x greater than 0 and y greater than 0 is nothing but my entire first quadrant. First quadrant. So the range space of my old values x and y are my first quadrant. Let me now find what is going to be the range space of my z and w. Now when I am going to find the range space for z and w, let me mark this as my w axis and let this marked as z axis. So let me fix as w, let this be fixed as z. Now what we know about x, I know that x is equal to zw, and what we know about y, we know that y equal to w. Y greater than or equal to 0. Y greater than or equal to 0. What will this imply me? W is also greater than or equal to 0. So I have got one quantity called as w greater than or equal to 0. What is my limit of x? I have x to be greater than or equal to 0, which now tells me zw. What is my x? X is zw. This is also going to be greater than or equal to 0. Now I have product of two numbers to be positive. When can product of two numbers be positive? When both of them are positive or both of them are negative, then I have that product to be positive. You can say that 2 into 3 if I multiply is going to be 6, which is going to be greater than 0. If I have minus 2 into minus 3, then I will be having this product to be again positive. 2 3s are 6. So either both of them have to be positive or both of them have to be negative. I have been said that one number is already positive over here. So this product has to be positive means the condition on the second variable is that this can happen only when the second number is also positive. So it gives me the relationship that z is also going to be greater than or equal to 0. So now I am ready to plot my regions w greater than or equal to 0 and z greater than or equal to 0. What is going to be z equal to 0? Z equal to 0 is your w axis. What is w equal to 0? W equal to 0 is my z axis. So now let me plot for the region which has been given for z greater than 0, z moving from 0 to infinity. So which direction? 0 to infinity. It will cover this entire space from 0 to infinity. In a likewise case, what will happen when I want to move from w greater than or equal to 0, 0 to infinity? So what will happen? 0 to infinity. So 0 to infinity, the entire of the range over here will be covered for. So what you will be covering over here is going to be your entire of your first quadrant again. So this quantity is at greater than or equal to 0 and w greater than or equal to 0 is again the first quadrant entirely and the entire first quadrant. So we are now defined what is going to be the range space of my z and w. Now we are going to fix the last part of it. Find the required PDF of z as per the requirement. What is going to be given as my f of z? My f of z is going to be integral of the new function f of z comma w with respect to w. So this is going to be integral of what was my new function which I have derived? 3w e power minus w into z plus 3. So 3w e power minus w into z plus 3. This has to be integrated with respect to w. Now fixing the limits for w. How will I go and fix my limits for w? This is my new region and now going on with my w axis. I want the w line and I want the limit for w. So what you'll have to do is draw a strip parallel to your w axis. So where does your w move from? W moves from 0 to infinity. So my W moves from, what is W over here? 0. What is W in the upper line? It is going to be infinity. So where does my W vary? W varies from 0 to infinity. Go fix this limit. W varies from 0 to infinity. Now we are ready to work out the problem. How to go about it? 3 is a constant, pull it outside. W is also a variable. E power minus W is also a variable. So make use of integral u dv method. Keep your W as such. Let us integrate E. E power minus theta on integration gives you e power minus of z plus 3 divided by minus of z plus 3. So the second term is going to be negative. W on differentiation gives us 1 and E has to be integrated one more time. So z plus 3 divided by minus sign will become plus when I square it, and I will have z plus 3 the whole square. The third term, what will happen? 1 on differentiation will become equal to 0. So the process of differentiation stops over here. Let us apply the limit between 0 and infinity. We need to keep two things in mind over here. E power minus infinity is going to be equal to 0 and e power 0 is going to take the value as 1. We can notice that we have e power minus infinity and e power minus infinity is to be substituted when I go for the upper limit. So what happens to my upper limit? My upper limit entirely vanishes for my quantity of upper limit minus infinity. So it becomes 0. So no upper limit exists. Let us go for the lower limit. What is the lower limit? Lower limit is 0. When I multiply this w with as 0, replace this w as 0. 0 into something is going to give me 0. So what will happen? This term will entirely vanish for my both upper limit and my lower limit. Now coming to the second term, what will happen over here? E power minus 0. What is e power 0? E power 0 is going to be equal to 1. So I will be left out with 1 divided by z plus 3 the whole square. So this is going to be a negative sign. There will be a negative sign for your upper limit, which has become 0, minus of the lower limit. So this is going to be the quantity and we have a 3 common outside. So we have the function as 3 times of z plus 3 the whole square. So this is my function f of z. So I have now defined the PDF of f of z as 3 divided by z plus 3 the whole square. But keep in mind, we can complete the function only if we define the range of the variable involved. What is the variable involved here? Z. And what do you know about the range of z? Z is going to be greater than or equal to 0. Go and attach it along with over here. Z is going to be greater than or equal to 0. Now this entirely defines the PDF which is required. What is our f of z? 3 divided by z plus 3 the whole square, valid for z greater than or equal to 0. So quickly recollect all the 5 steps. What 6 steps? First, fix their auxiliary random variable. Next, find the joint PDF making use of the condition f of x and y are going to be independent, means f of x into f of y is going to be the formula. Now find the relationship of the new variables in terms of the old variables and then find the Jacobi of the transformation. Now the formula for the transformation is z comma w equal to Jacobi times the old function f of x comma y. Next, move on to find the range space of the new variables based on the range space of your old variables. And last, find the required PDF of the variable according per the requirement by fixing the formula by the marginal density functions. Thank you.